So it's a real pleasure to have Dr. Trevor Stammers back to us today. Mitochondrial replacement techniques were legalized back in 2015 in the UK, so they're very recent, and more recently in Australia in March of this year, ostensibly as a way to enable mothers with affected mitochondria to have genetically related children without fear of passing on to them the risk of severe mitochondrial disease. And in this webinar, Dr. Stammers will explain these techniques. He'll explore the controversies surrounding their legislation or their legalization and use, and will critique the capture of language in promoting them to the public. And he's going to raise questions about why they might be being promoted and whether they really work. And finally, if they're ethical, and to look at some biblical reflections on them as well. Dr. Trevor Stammers is editor of the New Bioethics Journal. He was formerly Associate Professor of Bioethics and Medical Law at St. Mary's University in London, and was a family doctor for 27 years before going into academia. And his latest book on the ethics of organ donation, interestingly written with Callum McCullough, who was our speaker last week, is called The Ethics of Generating Posthumans. So Trevor, it's a great delight to have you back again, and we look forward to being enlightened and to engage with you. Thank you.
Well, thank you very much, Peter, for that introduction. For those of you who may be watching and wondering whether this seminar will be of relevance to you, I will say right from the get-go that in preparing this talk, I very much felt that I should embed it within a much wider narrative that will apply wherever you're listening in the world. So although Peter mentioned that I would be sharing biblical reflections towards the end of his introduction, in fact, aside from my title slide of A Tale of Medical Mischief, I'm going to begin with a much more ancient tale and talk about something that's been increasingly on my mind in relation to this subject, but also many others. And that is the tale in Genesis of the deception of our ancestors by the one that the book of Revelation calls that ancient serpent, the devil. And in Genesis 3:1, you may recall that he said to the woman, "Did God actually say, you shall not eat any tree in the garden, eat of any tree in the garden?" And in one question, he both suggests that God might not have actually, I love that word in this particular translation, that God didn't actually say that. And he also changes subtly what God had said. And God actually hadn't said any tree, but the one tree. So this tactic proved extremely successful, of course. And he moves from suggesting that God may not have said it to then completely misconstruing and making the statement that God says that you shall not touch it either. And so moving from sowing doubt to flat contradiction. And truth is important in this context and in many others. And it is truly disturbing how bearing false witness in many ways is becoming the norm in my own country. And I prepared this talk well before events here today. And a Christian friend said to me recently in another context that God never gives us commandments without explaining himself to us and giving a reason for them. Now, that is not so, and God owes us nothing in the way of explanations. And although in the Ten Commandments, some do have a promise and one perhaps with a form of explanation, those commands are given because God is God, and these things are for our welfare. And the sowing of twisted presentation of reality is a very, very dangerous thing. It was in the Old Testament, and in the New, where the Lord Jesus says himself that I am the truth. This is surely a motivation, if we ever needed one, to make sure that we are honest in our dealings in an increasingly crooked world. Now, against that background, my first slide is a presentation from a newspaper article before the legislation of the technology I'm going to be talking about. And I'm just going to read the first paragraph of this. Imagine there was a law which prevented 150 children a year suffering from life-threatening disease receiving a transplant. Yeah, just imagine that. That would be unethical. So far, so good. But this is precisely the current state of affairs surrounding 150 children every year in the UK suffering from mitochondrial disease. Now, that, with respect, is very misleading. There was no such law. The application with transplant is completely erroneous. And even now, the technique that the bioethicist here is wanting to push with that arresting beginning, by playing the sympathy and parallel card, that technique is not going to save any of the children with this disease alive in Britain at the moment. And this is a typical example of how any new technology is misrepresented in the media, either consciously or unconsciously, through a desire to want to do good and to heal. But when the truth is sacrificed, we begin to get into difficulty. Now, sure, my colleague who wrote that in The Guardian and I both know that these mitochondrial diseases are frightful and hideous things. And as Christians, we believe they are part of what entered the world through the first tale of believing lies. But they are here and they are serious, and none of us, as these pictures show, could wish anything other than being able to help children with things like Lee's disease or myoclonic epilepsy with red-ragged fibres, which are just two of these disorders. And they result from defective mitochondrial functioning. And the mitochondria are the energy source of the vast majority of cells in the body. And so it's not surprising that the disorders that result from the faulty DNA within them are multi-system disorders and cause multiple devastating problems. So the seriousness of them is not in dispute at all. But the proposed method of trying to, as it is marketed, cure these, it's actually a way to try and prevent children being born with them, which is slightly different, but importantly different. It was proposed in several different ways, and I'm going to explain as simply as I can the first two. And I'll try and go fairly speedily with this. This figure shows the would-be mother who has the hereditary problem that's going to be passed to her children in her mitochondria. And below her egg cell is a donor egg cell. And in the maternal spindle technique, which uses an egg and egg donors, the mitochondria are not actually transferred. They remain in the cytoplasm of the donor cell, but the nucleus of that is taken out and replaced with the mother's nucleus, which then goes into the donor egg and is then fertilized with the intentions of having a normal child. But part of the problem with this and the next technique actually is that it's a bit like trying to separate the yolk from the white of an egg. If any of you are cooks, you'll know how difficult that can be to do it perfectly. And when the mother's nucleus is transferred, it is impossible to not transfer some unhealthy mitochondria as well. They may be proportionately fewer, but they are transferred, and that's important, as we shall see later. Now, the other method, which is similar, and that's why this diagram looks identical, but it's important to stress that here we are not dealing with egg cells, we are dealing with embryos. And so the same technique is used to transfer the pronuclei from a fertilized egg. So from the parent's embryo, they are transferred into a second donor embryo. And so two embryos are disrupted or destroyed in order to create the new embryo. So this method of doing it introduces the further complication, if you like, that if you believe, as I do, that our existence begins at fertilization as a unique individual, one is destroying two of those individuals to try and create a healthy one. Now, that diagram doesn't make that clear, and that's why in teaching I usually use a diagram from a different source, which makes it quite clear that 4 people are involved in the creation of the embryo by the pronuclear transfer technique. Now, it was said that the mitochondria are just like the batteries in our cells, in our cameras and whatever, and that doing this is just like changing a battery. And if I heard that said once during a parliamentary debate, it was repeated everywhere. Now, this is entirely fallacious. Even the revered Nuffield Council said that the brand of battery doesn't affect the function of the camera. Well, that's true, but the mitochondria are more like power stations. They generate the power, and changing a nuclear power station is a much more complicated thing, especially when you may have thousands of them within a cell, than changing the batteries in a camera. So that was very misleading. And then it was said, oh, this isn't really 3 or 4 parent IVF. And of course they wanted to say that because that's an inconvenient truth that would alienate the vast majority of the Catholic world and the many Protestant Christians who believe that the instrumentation of life in this way and the research that goes into it, which intrinsically involves wastage of embryos, as it's termed, are not ways that it is right for us to go down. But if a child is successfully born in this country with this technique, or in Australia, which is the only 2 countries that have legalized it, and there are no children born by it at the moment, and something goes wrong, you can be absolutely certain that the lawyers will want to know who contributed the mitochondrial DNA in the court cases that result. And so those 3 or 4 parents may well get involved even though they don't exist. That's just to emphasize the point that in some of the techniques, there can be 4 people whose genetic material has contributed to this child. And then it was said that this isn't really genetic engineering. Well, well, really. It was also said that it's not germline engineering. That's to say that the changes will not be passed down through the generations. But in fact, it certainly will be passed down through the female germline. So that's not true either. Then it was just a few genes. And this is very clever because in comparison to the certainly tens of thousands of genes in our nuclei, a mitochondrion does only contain about 37 genes, most textbooks will say. But of course, it's not a fair comparison because you've only got one nucleus in a cell. And whereas the number of mitochondria in a cell may vary from none in a red blood cell to 100,000 or more in a female egg cell, if you multiply up by thousands of times the 37 genes, you'll actually have more genes being transferred in mitochondrial donation than in nuclear genome manipulation. So that was an unfair move as well, and just piped out by people who really knew better. I mean, geneticists know this. And to say it was just like a blood transfusion in Parliament was a double whammy, really, because the blood transfusion, all the effects of that will be gone within a matter of months, and erythrocytes, which form the bulk of it, don't have any mitochondria in them anyway. So it was a completely misleading analogy. Now, to give them their due, some scientists did pipe up and say that there was an uncertain future from this technique, both because they were uncertain as to whether it would work and because of the ethical issues. And it's interesting that the first baby to be born at risk of genetic disorders from the technique with Professor John here was born in a country where, as he said, there are no rules. So this scientist broke the rules that apply in America where he practiced in order to be the first. And I did not know, and I don't know how to find out how this baby is doing. Of course, being born now, one wishes this child well, but there are ongoing concerns that make it very convenient for a child to be born in a country where there are no rules, because there may not be any follow-up either. And the second baby to be born with this technique broke a lot of rules because this baby was not born to a mother who was at risk in the first place. And this brings me to another, I think, great global deception in regard to this technique. Because the second baby, as it says here, was born to an infertile couple. And I mentioned about the mitochondria in an egg cell being hundreds of thousands. And it was realized at a very early stage that this treatment could be very useful in fertility work. And with the numerous infertile couples in the world and postmenopausal women seeking children, it is obvious that if the technique works and is safe, the multi-million-pound payoff is going to be in the fertility industry. And although I am sure that the clinicians who are pediatricians and looking after children with genetic disorders are quite genuine in this work, wanting to help mothers in that situation, it's going to be by far outweighed by the use in the fertility industry. And I looked and saw that about 8 children seem to have been born worldwide with it now, most of them in the Ukraine, and with very scanty details as to, most of these seem to have been in the fertility sector and not as helping those at genetic risk. And the American National Academy's report in 2016 specifically limited experimental work in this field to those who were at risk of mitochondrial disease, not for fertility work. So all of the work that is going on worldwide out with these rules is probably being directed into that line anyway. And part of the issue that I discovered only this week is that it was only in 2019, and this was legalized in 2015, that a more accurate way of predicting the disease risk was perfected through this research. So it was licensed for therapy even before detection had become really as accurate as it is now. There was lots of safety questions from animal models. The two different techniques I described, some of them, only one technique will work in one species of monkey and it won't work in another species of monkey, as far as I know. Nobody's explained why that's the case. There was a similar process being used in the US some time back, where they injected donor mitochondrial DNA cytoplasm from donor eggs, and that was abandoned after quite a number of the children had disorders such as Turner syndrome, something in the region of about 30 patients, of whom 2 had Turner's, and there were various other problems, so they stopped it. I'm not going to go into the next two for sake of time, but mitonuclear mismatching, we know that there is messaging going on between the nucleus and the mitochondria in every cell. And previously work was being done to treat these disorders by looking at that messaging and see if therapy could be directed towards it. Now all the money is going to this, and that work is probably very underfunded and certainly not aided by this diversion. And I'll talk about perhaps haplotype mismatching later, but I will just say here that when the abnormal mitochondria are carried over from the nucleus, like the albumin from the egg yolk, into the cell, if there is a severe mismatch in the sequencing of the mitochondrial DNA between the donor and the mother's cells, then this may stimulate the proliferation of the carried over disease type, and you may end up manufacturing or worsening the very disease that you were seeking to cure. And so it's not a case that any egg will do. That was a myth that was propagated widely at the time. And now most scientists are agreed that any egg will not do. And this brings me to the ethical issues. I've already mentioned the embryo destruction intrinsic to one of the methods. The commercialization pressure to obtain eggs has already caused problems in things like cloning research. And the impression was given by one newspaper that you didn't really need eggs, you only needed a little bit of mitochondria from a donor, but eggs are obtained from women, and it is not an entirely risk-free process, and there is plenty of underhand dealings in the fertility industry across the world with putting pressure on women to donate their eggs, just as there is with organ trafficking and so on. The genetic changes will enter the germline, and very careful thought needs to be given about monitoring these children and their children, if indeed enough are born. And the mission creep to fertility treatment, I've already mentioned. And as I just warned Peter that I am coming into land, it is worth thinking about where will all these eggs come from, because as a general practitioner, it always struck me, quite aside from the ethical issues, that IVF is probably the only treatment that we were routinely asked to refer patients for, where the vast majority, in many units at the time, 80% of them, would be disappointed. And it's not an efficient process, even with unmanipulated eggs. But once you start manipulating them in the way that is needed here, the efficiency drops altogether. And it isn't a case of, in this case, any egg will do. And as part of the post-seminar package, I'll send out an article by my colleague, Donna Dickinson, about the likely impact that this will have on women across the world, should this ever take off. The Australian approval of this, as Peter mentioned only a few months ago, to me was deeply, deeply distressing because of the lack of evidence that it works. I was on a television program before it was legalized here with a mother who was spearheading the campaign to get it legalized because she had had and lost a number of children and was desperate for a cure. And I tried to explain on live television the difficult message that doctors sometimes promise things that they can't deliver. And it was a really difficult interview, one of the most difficult I've ever done. And it gives me no pleasure at all to say that it looks like this technique is not in its present form working, because a baby was promised here within a year. We're now, what, 7 years on, and still not a single baby born. And why did Australia approve this? And particularly, some of my Christian friends in Australia were greatly distressed that a Christian Prime Minister, I gather, as he then was, who worships regularly every Sunday at his local church, was hoodwinked in the same way as our government were into voting for this, because it was being marketed as a therapy. If it is a therapy, it needed for sure a lot more testing, despite things the contrary before it was launched. And there are many technical problems, I think, to be overcome. Now, I'm not saying that either in the UK or in Australia, it may not succeed. It may succeed in a birth such as the first one for a mother at risk. But clearly it's not going to help the 150 children that were being talked about at the beginning for quite some time, if ever. And my own feeling is that gene editing is probably going to make this technology redundant in due course in terms of actually preventing disease. So beware, beware those who seek to market something in terms of a cure that may at worst be a dead end, and at best be a dead end, and at worst may lead to two embryos being killed in order to try and create a healthy one.
Thank you very much, Trevor. We've been listening to Dr. Trevor Stammers on the subject of mitochondrial donation. And I'd certainly been wondering why we'd heard so little about this since all the fuss a few years ago. And you've helped to enlighten us about that, Trevor. So we've got a time now for Q&A. Trevor, I wonder, just first of all, given that there are 150 people born each year in the UK with mitochondrial disease, given there are several different types of it, we've had 5 or 6 years now since this all came up. I mean, that's almost 1,000 children you would think have been born with this condition. What do you think is happening? Are parents just not seeking this legal so-called treatment, or are they doing it and it's not working? Why are we hearing so little about it, do you think?
that's an extremely good question, and the absence of any information concerns me greatly. I think our media is now so concerned with spreading good news that negative news doesn't get reported. And of course, in the world of medical publishing, for many decades, negative findings and non-events don't get a look in. And I mean, the thought is just crossed my mind that you know, it may be worthwhile asking or getting a parliamentary question asked about this. And certainly if Australia didn't ask it before it legalized it, somebody ought to have done so there. And we simply don't know. I think it is extremely unlikely that there haven't been attempts, but we just don't know. And every week I check to see whether the promised baby has appeared, but it has not.
Because you would expect, wouldn't you, that if it was happening and working, then every case would be trumpeted on primetime television. And but if it is the question, are they trying it and it's not worked, or are they trying it and it's had bad results that they don't wish to report, or are they just not trying it? It's just astounding the deafening silence that we're hearing on this, isn't it?
Who can tell? And again, you know, on a global basis, it was quite hard work to find out, you know, the total number of babies born, but assuming that the total of 7 or 8 that I've come across, the vast majority in one particular center in the Ukraine, again, that makes one wonder how many failed attempts, even for fertility treatment, have occurred as well. You know, there's always a price of failure to be paid, just as sadly in IVF, with all these reproductive things, every advance means success in terms of the awful phrase, the take-home baby, and heartbreak, and sometimes financial ruin too for those parents who paying thousands of pounds for disappointment sometimes. It's really sad.
You've said regarding these cases in the Ukraine, and indeed it seems to be Ukraine where most of these successful babies had been born, that it was being used for infertility treatment. What particular types of infertility are they addressing, and why are they using mitochondrial donation for those types of infertility?
Well, obviously this technique of mitochondrial boosting, if you like, of re-energizing egg cells, as I understand it, will only, and it's not going to be of any consequence with tubal infertility or whatever. So I think it's mainly in terms of regenerating the egg and bringing it back to life again. And if anyone on the call has more expertise in regard to that than myself, do pipe up in the chat line. But it's quite difficult to find out information about certainly the clinics. But there are papers out there talking about its use in infertility, obviously.
I remember when this was first being talked about, there was a lot of play made about the fact that with this technique, you could have a baby produced that had several genetic parents, one producing egg, one sperm, one mitochondria, and so on, and that it might be attractive to infertile couples who were had chosen to use sperm or egg donation as a way of ensuring that genetic material from both parents could somehow be represented in the baby. Have you heard much about that? And do you think that that's played much of a part in driving this technology? You said earlier on that you wondered if it wasn't so much mitochondrial disease as other applications that scientists could see, but needed the mitochondrial disease, you know, as a Trojan horse, if you like, to get it accepted.
I wouldn't be as sort of calculating as that. And I personally think that the expert who's been leading this for children in the UK comes across as nothing but an honest clinician who is really genuinely wanting to help his patients who wanted to have genetically related children, but they were getting these diseases and dying, and that's a very positive motivation. But it was mentioned at the time, and I think in that very paper that I alluded to, that other methods of having children are there, but not necessarily genetically related. And it's difficult because there is this, obviously, a desire to have children of one's own. But I think the older I get, the more I realize that the biblical pattern of us entering into God's family is that of adoption. And with the increasing need worldwide for adoption, it certainly seems to me that we need to be talking about that more in many situations, not just this one, because an adopted child is also a child of one's own in a different way.
Thank you. There's a question here from Rodney Burnham. Are your concerns not mainly theoretical, and perhaps gene editing will be the better future option for these difficult problems? So could you talk a bit about other treatments for mitochondrial disease? Are advances being made using alternatives to mitochondrial donation? And in particular, does gene editing somatic gene editing particularly play a role in the treatment of these conditions?
I think obviously with any technique that's being pioneered and hasn't been tried before, objections initially are going to be theoretical. But I think the fact that we're now 7 years on and there are so few reported cases, and only one or two at most actually successful in mothers at risk of the disease, show that those concerns are actually not theoretical now. There is a very real problem with this technique, and it was pointed out by many cell scientists that I spoke to, not clinicians, but those who are in the business of cell biology, before this went forward. And I mentioned briefly in passing that there was research, and it possibly still is going on, looking at whether there would be some mechanism whereby the faulty mitochondrial messaging with the nucleus might be in some way interrupted or put right. And I'm sure that genetic editing techniques, and certainly with the advent of CRISPR, hold far more promise of successfully dealing with this issue at some point in the future. The sort of mitochondrial mismatching thing seems to be a major problem, and it certainly is proved to be in work with mice and rats and so on.
Can you talk a little bit more about that? You mentioned haplotype matching and saying that you can't just use any egg, that there are interactions between certain eggs and certain nuclei. Can you give us a bit of insight about how haplotype matching is done, whether you can predict in the future which eggs you can use and which you can't? And particularly what research in other species has told us about the problems that you can get from this technology?
The short answer to how it's done is no. I can't explain. I can't explain that. It is very, very technical, but certainly work in mice, and I think also in monkeys, has shown that it is important. And there are obviously ways of sequencing the mitochondrial DNA and finding whether you've got a sort of near match or a distant match in the mother cells and the potential donor to be able to regulate it to a certain extent. But the problem seems to be that if the haplotyping is not compatible, that this will stimulate the growth of the faulty mitochondria that are carried over from the transfer of the nucleus from the mother.
Yes, and I found your analogy of the yolk and the white very, very helpful, because the battery analogy, of course, you think it's very easy to see the difference between the battery and the appliance, and it just clicks in and out with no transfer of material from one to the other. And yet, as you were saying, with mitochondrial transfer, it's impossible to transfer the nucleus without taking a bit of cytoplasm and therefore mitochondria with it. And so you could end up, if that is accelerated or potentiated by the process, of creating a worse problem in the future.
Yeah, I've been doing much more cooking than ever before in retirement, and if you see what problem with the egg and albumin does to a meringue or a Charlotte Russe mix, you can, well, certainly in my kitchen, you can see what might happen in a cell.
Well, perhaps the subject for your next book. Paul Adams is asking a question about regulation. He's saying we have, when it comes to medicines regulated by the MHRA in the UK and by similar regulatory bodies elsewhere, there are very rigorous checks on safety, efficacy, quality criteria, and so on. What's going on with regulation here, and who's responsible for it? Is it the HFEA? And if so, are they scrutinizing what's happening? Did they scrutinize the science beforehand? Are they reporting on it? Some comments about regulation.
Well, the HFEA is responsible for oversight of this research, and as with the USA, it should only be used for trying to prevent disease and not treat infertility. But I don't know whether they have reported on its advance, but I certainly will be inquiring after, because you just put the idea into my head, inquiring about how this is going, and see what sort of response I get. Others listening may wish to do the same.
Well, as you say, I think it's a great question for a parliamentary question once the current parliamentary storm settles down. On the ethics of the subject, Trevor, now, of course, there's, with anything involving embryos, there is concerned about the status of the embryo, and particularly in a technology where embryos are effectively being destroyed and reconstructed like this. Are your ethical concerns about it related solely to concerns about the status of the human embryo, it's an early human being, or are there other ethical issues which you think are unique to this particular process as opposed to other embryonic techniques?
I think there's a sort of three-part answer to that one. As there is the status of the embryo itself, about which I haven't always felt as I do now, and it's since, I think, doing further studies in bioethics that I've become convinced on a biological basis, rather than primarily a theological basis, actually, that conception, fertilization is biologically the only sort of rational point at which I began. And although it's probably not the place to go into the details of the counter arguments, which will flood to mind as they did with me at one time about that. That to me is important. This sort of research, along with cloning research and much other fertility research, does require eggs, and I think it's anyone who has seen even the trailer for Jennifer Lyle's film Exploitation will realize that this is not a nice business in many parts of the world. And it's interesting, isn't it, that it's in this field of cloning, genetic engineering, that several giants like Professor Huang and more recently Professor He in China have gone to jail, and in part Huang's misdemeanors were coercing his own female research members. So there is the irony that reproductive medicine promises liberation for women, and yet exploitation still continues to be targeted from men against women. And then thirdly, there is the whole issue of is this is it healthcare in the sense that infertility, although it may be caused by disease, is childlessness a pathology? And that again sort of takes us out of this particular micro line of inquiry to a much broader discussion where there will be much more difference of opinion. And people may rightly say it's okay for me. I have 3 children, but that doesn't mean that I can't empathize with the pain of not having children.
Yes, it seems to be it's much more specific than that, isn't it? Because it's about the pain of not having biologically related children. Because as you pointed out earlier, and someone's already highlighted this in the questions here, God's act in bringing us into his kingdom involves adoption. And there's been very strong support, of course, throughout the whole of Christian tradition, the whole idea of adoption as a solution, not just for orphan children, but also for childless couples as well. And why do you think so much effort is going into using a technology like this to create children who are genetically related to the parents, when there is still some risk involved, as you've already pointed out, of it not eliminating the mitochondrial disease anyway, rather than just promoting other avenues, and most of all, adoption?
Yes, I think that's a very important, broader question. And of course, the opposite side of the coin, I suppose, from what we've been saying about the spiritual aspects of adoption, is that the command to be fruitful and multiply is also one that certainly is a theme that runs through Scripture. And there are those who were infertile who prayed for a miracle and so on, and God blessed them. And it's not just solely a cultural phenomenon, although that does affect it. But there does seem to me, and I'm sort of thinking as I go here, that perhaps this is part of what it also means for us as men and women to be born or to be created in the image of God. That God the Father reveals himself as such, and of course, in one sense, created all of us. So I think that that drive is a good thing, but living in a fallen world, there are many good motivations which for various reasons may be thwarted or prevented. And the older I get, the more I realize that part of our discipleship is that we take up our cross and deny ourselves. And at some point, with all sorts of things, that if there is no cure or human remedy, we have to learn to praise God and worship him, even in the absence of what might be ideal. It's hard. Faith is not easy.
Yes, and I guess that raises a question that's been asked here by Yusuf Deng. Given the ethical concerns and given the pain also of having a child with mitochondrial disease, what would your advice be to Christian couples who had a high risk of mitochondrial disease, but wanting to do the right thing, but desperately wanting a child?
I guess it's not too difficult to predict that the first thing that I would say is that, in my view, the promised cure at the moment is not at a state where it is efficient enough and safe enough to be a route that I would recommend, and certainly given the present state of knowledge, not a route that I would think about going down myself. And then more positively trying to encourage them to wait until possibly a true cure is found for those children who are already alive and have the disease, or a way is found via genomic editing that possibly makes a cure possible. I think that's probably the line I would go down, and again encouraging the thought that having children who are not genetically related by adoption is still a very good and necessary way of parenting in a society.
I remember when this technique first came about, there was a suggestion that it might be of interest to same-sex couples. A lesbian couple, for example, could have a child who was genetically related to both of them by using the cytoplasm from the egg of one and the nucleus from the egg of the other, and a sperm donor. Do you think that that's played any part in promoting this, or have you heard any interest from the LGBT community about this technique for that reason?
I haven't any knowledge of that, and I've got no reason to think that this technique would particularly play into that, because these are pretty rare, and the chances of having both potential mothers within a lesbian couple of both having faulty mitochondria is obviously substantially less than just one. So yeah, I don't think that it's going to play much of a role in this technique.
No, it would be for a lesbian couple who were both completely normal and unaffected, but the technique would enable them each to be genetic parents of the child. So use the mitochondrial replacement technique, but to get the cytoplasm of one and the nucleus of the other, if you see what I mean.
Oh, right.
Either with maternal spindle or with pronuclear transfer, you know, so you could do it either before or after.
Pardon my innocence. I thought we were talking about somebody who was at risk of having a child who might have one of these conditions. Yeah, I've not come across anything in regard to that, but it may be out there. I've learned a lot from this afternoon, as well as sharing a lot.
I guess. Well, I think we've all learned a lot this afternoon, and although we don't necessarily come away with all the answers, you've certainly painted the picture for us and given us some very clear principles and evidence to go on. So thank you very much, Trevor, for a incredibly stimulating talk and for the questions. So God bless you all. We look forward to seeing you again soon on ICMDA webinars. Thank you.